So let's start with the simplest of the components for Hangman, which is this custom block letter. Letter is in Word, um, which is a predicate because it has the angled sides, which means it will return true or false. And this is useful for when you have the letter inputted by the player and you want to see if it's in the word that they're guessing. This is the basic conditional that you fork the logic off, whether they got it right or got it wrong. And we have a simple test script here, which has two global variables, correct guesses and incorrect guesses, that we immediately set to empty lists. We have a variable called letter, which holds the letter A right now and is used in three places, as input to the custom block and as input to add to either of the lists based on whether the guess is correct or wrong. And so if we were to try this right now, we have letter A is in Word. It ends up in incorrect guesses, which is correct. But let's look at another one, and intuitively know that W is in the word Word, and it also ends up incorrect guesses. And that, of course, is because the block is incomplete. We have not done anything to it. It reports empty, which ends up being false. So if we were to do the simplest thing and report true, apply, run again, then it ends up in correct guesses. But we can't just hard code it. We put it back to A, ran the script. A ends up in correct guesses again, but it's not correct. A is not in the word word. So let's actually fulfill the requirements here of the block. And I have definitely noticed some people doing something like this, where they might have an if statement. Let's use if else, actually. It's just if, because that's what I've been saying. If statement, if letter equals W, report true. If letter equals O, report true. So obviously this is not a good idea, because then this script can only work for the word word. But we want to be able to put in a different word, for instance, apple. We have to report at the end, or else everything gets stuck. So let's put a report false at the end here. So if A is an apple, but we get A as an incorrect guesses because this was hard-coded to be W, which is a little silly. We have the word word in here, or now the word is apple, as a variable. So we should use that to test what it is. And there are multiple letters in the word that we get through this variable. So the easiest thing to do would be to loop over each letter and check to see if it exists in the word. Looping over words is a little different than looping over lists, but not by much. It's still conceptually the same. You still need a counter variable. So we'll make a script variable and call it counter, which starts at 0. And we need a repeat loop. We need to repeat, in the case of apple, 5 times, in the case of word 4 times. It needs to repeat the length of the word. There's a couple different word operators down here that make this easy. So just like there's a length of list block, there's also a length of word block. So this will be 5 because it's apple. So you can watch this value of apple travel into the block as the variable and then be used here. So apple will end up here. So we'll repeat 5 times. And the first thing we do in a loop is we increment the counter. So we need to change counter by 1. That lets us look at each letter. Let's just test that real quick. If we do, we're going to say something for 2 seconds in each loop, but what do we say? Well, just like there's item blank of list, there's also letter blank of word. So counter will be 1, 2, 3, 4, and 5, and word will be apple. So if we run this, let's just report false at the end there still. This sprite will say A-P-P-L-E. Should have made it faster. 2, 3, 4, and 5. So that's how we know what letter we're working on. It's this letter counter of word. But we don't want to say it, we want to do a test. We want to see if this letter equals equal to this letter. And if it is, we know it's in the word. And if it's not, we know it's not. So let's get an if block. We want to see some equality here. We want to see if the letter equals the current letter in our block. So if A equals A, then A equals P, then A equals P, then A equals L, and then A equals E. Though this will actually finish early because we'll know A equals A. We know that's true. So we'll just go ahead and report out true. We can just finish everything here. And this will actually work. We hit the green button. A is an apple. Let's test it again. B is not an apple. C is an apple. Is not an apple. P is an apple. L is an apple. And E is an apple. Now we can go back to the word word and make sure it works for different words. So E is not in word, but R is. So it shows up. So that's the whole block. You loop over each letter. You test to see if the inputted letter is equal to the current letter of the loop, and you report true if that's the case. Otherwise, you report false. So basically, this loop goes through, it checks each letter, and will actually stop. It will end the custom block once it gets to report true. It may not get to report true, though, so then it'll fall all the way through to report false. One student actually made this a lot simpler, and I was really impressed by that. Remember, we looped over this like a list, and you can actually convert a word into a list very easily. It's another one of these word operators. We took word and we split it by letter. We now have a list. Let's just take our current word variable, which is called word, and let's overwrite it. Let's replace the word variable with a list that has all the letters. And if we say this, we can see what happens. We'll also need to report at the end, or else it'll never finish. So let's say word now that we've converted it to a list. So set a list. Set it for 2 seconds, then I'm finished. Now there's already something contains something block, which checks to see if we can use to check to see if the letter is contained in the list. So there's a predicate, which means we can actually just use that in place of report. And now we have an even simpler version, and it works just as well. R is in word. W is in word. A is not in word, but it is an apple, as well as E. So, bonus credit for anybody who comes up with this version. Way faster, way easier to read, and works just as well.